Welcome back to lesson 2-2. This is video B, or the second video in this lesson. What we're going to do is we're going to add and subtract some rational expressions. That we're going to do. But we're going to start out with, if you missed the first video, make sure you watch it. It's talking about excluded values. We'll touch on this in this episode of Schwarberg Math. We'll talk about those. Okay, so make sure you have knowledge of that. What I want to do, we're going to start off adding fractions. Okay, so we're asked to add these fractions. This is very important, especially when we're dealing with rational expressions, because rational expressions are fractions just with variables. So if you were asked this problem in elementary school, I believe 5th or 6th grade, you deal a lot with fractions, right? If I want to add these together, you have to have a common denominator. Are they the same? No, I can't add 9/10 and 5/8. What is this madness? Okay, so what you have to have is you have to have a lowest common denominator. Now I need a number, right, that I can turn both of these fractions into, turn the denominator into it, right? So in this case, right, the lowest common denominator, this comes from what we call the lowest common multiple. So a lowest common multiple is just where you multiply the number times 1, times 2, times 3, times 4, and so on and so forth until you find a number that they share, right? So if I multiply 8, 16, 24, 32, 40. Hey, 40, they match. That's the lowest common multiple. Okay, so in this case, our lowest common denominator is going to be 40. But I want you to think about lowest common denominator as kind of like the breakdown of the factors. And in higher order mathematics, we call it a prime factorization. If I can break down a number into nothing but prime numbers. Okay, so if I take 10, well, 10. Isn't that 2 times 5? Yes, it is. It is, okay? And then if I take 8, well, that's 2 times 4, which is also 2 times 2. So the prime factorization of 8 would be 2 cubed. Okay, so 8 is 2 cubed. Okay, for this lesson, you're not going to need to know prime factorization, okay? And I bring it up just so you understand the idea of breaking down a number into smaller pieces, okay? So the LCD and how we're going to think about it in this class is you're going to take, for the LCD, you're going to take what factors are the same, okay? And if you agree, look at 10 and 8, you agree there's 2? I agree, okay, me too. And then what you're going to do, you're going to take the factors, which is a different color, that are different. Okay, and that would be 4 and 5. Okay, so the factors that are the same, right, that are matching is 2, and the factors that are different are 4 and 5. Well, believe it or not, this is how you find your lowest common denominator and the least common multiple. This is the algorithmic way. So 2 times 4, which is 8, times 5. Is that not 40? It is. What? Okay. So there's the lowest common denominator. And now just remember, if I wanted to go ahead and add these fractions, if I want to take 9/10 plus 5/8, I have to turn my denominator into that. So you introduce that missing factor, right? I have to multiply this top and bottom by 4. I have to multiply this fraction top and bottom by 5. Okay. And we end up getting, I'm just going to draw an arrow. I'm going to come over here. I like the sound effects. So we end up getting 36 over 40 plus 25 over 40. Okay. Can I add these now? Well, sure, Schwarberg. You sure can. Let me add my equal signs. Okay. So I have 36 plus 25 over 40. Which gives us 61 over 40. Okay? Hey, I added the fractions. All right, I made a bigger deal. I was extra. So what? Okay, here we go. Let's get into it. Our objective, add and subtract rational expressions. Here's the concept. You're going to add and subtract the rational expressions using the same basic procedure that we just did. Here are the steps in order to add. First, you got to find your lowest common denominator, okay? So I'll show you how to do that, taking the factors that are the same and that are different, put them together. That's your LCD. Step 2, lies. Here, do this as step 2. Step 2, find excluded values. Okay, you're 3, you're 4. Okay, so you're gonna find your LCD, you're gonna find your excluded values, and then once you have your LCD, you have to introduce those factors, right, into your 2 expressions by multiplying by a ratio of 1. This is very important, ratio of 1. Okay, if you're a highlighter person too, you can highlight lowest common denominator, excluded values, right? These are like the one-word things. LCD, excluded values, ratio of 1. Okay, and then last but not least, you're just gonna add. Okay, so those are the steps. If you need to refer back to them, refer back to them. Okay, I'll be talking about them. You can pause, rewind the video, do what you need to do to understand this. Okay, so here we go. Here is example 1. Please write this in your notes. And let's use purple. We'll use purple. Okay, let me find my notes. Okay, so here we're asked to add or subtract these given expressions and then state any excluded values. So just like I said, step 1 is to be able to identify your lowest common denominator, your LCD. So how do you find your LCD? Well, what you have to do is you need to factor your expressions. So just make sure that the denominator is broken down so you can see the factors. So I'm going to rewrite this as 2x over x plus 4 times x minus 5 minus 5 over 3 times x plus 4. And yes, you need to take out any GCFs and stuff that you have, okay? So I factored this, and then again, I'm going to play this whole game of what's the same and what is different. Okay, if Miss Page explains this a different way, please think about it whatever way that she does. She's a pro, she's an expert, okay? So, but here, so what's the same? Well, I know that they both have an x plus 4, right? Okay, so my LCD has x plus 4. And then what's different? Well, there's x minus 5. Minus 5? That's supposed to be a plus. Make sure that's a plus. Plus 5, okay? And then there's also a 3 here, so multiply by a 3 out front. So boom, there's your LCD. 3 times x plus 4 times x plus 5. Easy. Okay, so step 2, I told you to add this in. Hey, that's a different purple. We'll roll with it. You need to find your excluded values. How do you find your excluded values? Well, you're going to take your denominator, you're going to set it equal to 0, right? That's what we talked about in the last video. Okay, so here we go. I'm going to take 3 times x plus 4 times x plus 5, set it equal to 0, and I'm going to solve. 3 equals 0. What? No, it doesn't. We throw that out. Okay, just ignore the coefficients. Poor coefficients. X plus 4 equals 0. X plus 5 equals 0. Okay, then you solve. X equals negative 4. X equals negative 5. Those are your excluded values. Plain and simple. Okay, here we go. Here's step 3. This is where it starts to get a little bit tricky. Okay, so what I'm going to do is I'm going to rewrite my term. So 2x over x plus 4, x plus 5. Okay, minus 5 over 3 times x plus 4. And I'm just going to introduce my missing factors. So I want you to look down here. Okay. What's missing? What is missing? Well, if I look at my LCD, I'm missing a 3. Okay, so what are you going to do? Well, I'm going to introduce the 3. I'm going to multiply by 3, top and bottom. Okay, I'm going to look again. What's missing from here? Hey, I'm missing the x plus 5. Okay, so I'm going to introduce that. So I multiply top and bottom by x plus 5. Okay, so let me zoom up here. So here's our next line. 3 times 2x gives us 6x over our denominator. 3 times x plus 4 times x plus 5. Okay, minus 5 times x plus 5. I would go ahead and distribute this right away. So what's 5 times x? 5x. It is. And 5 times 5, that's 25. I'll deal with that negative out in front in a second. So if you're worrying about that, chill. Okay, good. So that's essentially step 3 right here, right? I introduced those missing factors, and now look at the bottom. It's the same. I can add them together. I'm super excited. This is easy. It is easy, okay? But watch out. It's a trap, right? Admiral Akbar here to tell us, watch out for this negative. What's this going to do? Well, it's going to affect this sign value, and it's going to affect this sign value. So what do we get? Okay, well, I'm going to get, trying to switch my pen color back to black. Okay, so I have 6x. Now here's where that negative comes into play. I got to change that sign value, right, of this whole term. So negative 5x plus, or that whole binomial, not plus, minus 25. Okay, and again, that's because that negative, right, changes all of those signs. So over our denominator, okay, equals x minus 25 over, I'm running out of room. You guys are probably like, I ran out of room 5 years ago. These notes don't have enough space. I agree. You can use other paper. Okay. And here's our answer, except now, remember, include your excluded values. What are our excluded values? Boop, right here, okay? So we say, okay, x cannot be -4, -5. That's it. Hey, I added 2 rational expressions. Look at you go. You guys are killing it. All right, so we're at 12 minutes. I'm trying to make myself bigger again here. Here we go. Look, woo, there I am. Okay. We added and subtracted rational expressions, okay? So in the next videos, I'm going to cover an example. There will be some practice problems. Make sure you watch those. And then this is actually looking like it's going to be a 4th video. So on the 4th video, I'm going to cover some different types of examples. All right, catch you next time. Peace.